Hi everyone, it's Math with AUB. Today we are about to discuss some tiny MCQs on vectors. I've selected the topic vectors. We have done 2 to 3 frames on vectors. Still I feel some thirst. Let me quench my thirst in order to give you comprehensive picture of vectors at your entrance levels, whether it is at subjective level or examination level. How to work with vectors, let's see and find out. MCQ number 1, magnitude of A cross B. Magnitude of A cross B represents the blank of a parallelogram. Magnitude of A cross B, magnitude of A cross B represents blank of the parallelogram. Let me draw a parallelogram for you. Okay, in parallelogram, no angle is of 90. That's our A. Suppose opposite sides are equal. It's our BB. Okay, if I drop a projection from this point to this, it is angle of 90. Suppose the angle theta, that's the height. That's the height. Apply sine, perpendicular divided by hypotenuse, it's our sine theta. Sine theta is equal to hypotenuse over base, or solve for height. Height is b times sine theta. B times sine theta. Why I have chosen the ratio sine A cross B? A cross B is given by the magnitude of A, the magnitude of B times sine theta. That's why I have chosen sine theta. Okay, find its area. Height times this length. Height times A. Height times A. Height times A. Height times A. What is the value of height? That's B sine theta. So I can replace B sine theta. That's A. So it's AB sine theta. Let me give you complete picture. So A cross B magnitude is equal to AB sine theta. AB sine theta. It represents the area of the parallelogram. Area of the parallelogram. Height times length. Height times length. Height times length. Height times base. It represents area of the parallelogram. Area of the parallelogram. If you are interested to find area of a triangle, just divide by 2. Just divide by 2. Just divide by 2. Just divide by 2. It will become area of the triangle. Area of the triangle. So the magnitude of A cross B, where A and B are the adjacent sides of a parallelogram given by vectors, represented by vectors, represents the area of the parallelogram. Okay, moving to question number 2. What is the formula or identity for volume of a tetrahedron? What is the volume of a tetrahedron? Volume of a tetrahedron is 1 upon 6, the triple product of A cross B C. 1 upon 6 A times B cross C, or 1 upon 6 A cross B times dot C. These are the formulas for this one, and it is further given by 1 upon 6 A1, A2, A3, a vector in 3 dimension, B1, B2, B3, C1, C2, C3. Dot and cross are interchangeable. This is formula for volume of a tetrahedron. That is the formula for volume of a tetrahedron. 1 over 6. 1 over 6. Now, question number 3. MCQs number 3. Let me read this first, then give you a good idea not to mix the writing together. Yes. MCQ number 3. If A and B are parallel, if the vectors A and B are parallel, then what is the magnitude of A cross B? If A parallel to B, if A and B are parallel, what is the magnitude of A dot B? A dot B is given by mod A, mod B cos theta. Mod A, mod B cos theta. Mod A, mod B cos theta. And they are parallel. Parallel means either angle is 0 or 180. 180 degree or pi. In both the cases, you can find what, let's find out. First, utilize angle 0, mod A, mod B cos 0. Cos 0 is equal to 1, and it's given by the magnitude A cross B In typography, they are written in like this. Somebody has written with hand in the book. It is known as word in italics. Word and italics. Word in italics. They represents mod A times mod B. Word in italics. Word in italics. So they represents a magnitude. What about if we take angle theta? Parallel means either angle 0 or 180. 0 or 180. 0 or 180. Yes, neutralize 180 angle A dot B mod A mod B cos 180. Cos 180 or pi is tantamount to negative 1. Negative 1. So it's R minus AB. In case of magnitude, discard the negative sign. In case of magnitude, minus is meaningless. Minus is meaningless. So if A and B are parallel vectors, then the cross product of dot product of A cross A dot B is given by the magnitude of A or B, or it is written as AB, or written as AB. So A dot B is equal to A times B. A times B. The magnitude of the vectors A times B. Magnitude of the vectors, because scalar product results in a scalar, not a vector. Okay. Moving one step further. Question number MCQ number 4. MCQ number 4. Its identity, I think, yeah. If three vectors A, B, C are coplanar, lying on the same plane. Coplanar lying on the same plane. What the condition for coplanarity? Their scalar triple product is going to be 0. Is going to be 0. That's the option. That's the identity. Let me write for this. It's equal to 0, or it is written. It can be written as A dot B cross C, or A cross B dot C is equal to 0. When the vectors are coplanar, their scalar triple product or dot triple product is equal to 0. Is equal to 0. Yes. Now, A cross B, the result of A cross B is always perpendicular to A and B. A cross B, MCQ number 5. A cross B is equal to mod A mod B sine theta. In physics, you have seen some like n here, means the result of A cross B is a vector that is perpendicular to both A and B. A and B. The result of the cross product A cross B, it is perpendicular to A as well as it is perpendicular to B, or simply one can utilize the fact A cross B with dot product with A, it is equal to 0, because two vectors are perpendicular, the dot product is 0. A cross B dot B, this also results in 0, as A cross B is perpendicular to B as well as to A, as well as to A, as well as to A. So A cross B is equal to minus A mod B sine theta. Their result is perpendicular to the plane of A and B. Perpendicular to the plane of A and B. A cross B always results in a vector that is perpendicular to A as well as perpendicular to B, as well as perpendicular to B. And two vectors are possible. Two vectors are possible, whether you can take A cross B, the result of A cross B is perpendicular to A as well as B, as well as the cross product of B cross A. B cross A also perpendicular to A as well as B. Now question number 6. For non-zero vectors A and B, A cross B is a unit vector. A cross B is a unit vector. It's given to us. The magnitude of A cross B is unit, and furthermore, magnitude of A and magnitude of B both is equal to square root 2. Then we are asked to find inclination, angle. Utilize cross product. A cross B is equal to mod A mod B, magnitude of B sine theta. It is given to us A cross B is a unit vector. A cross B is a unit vector. It's equal to 1. Their magnitude is under root 2. That's also under root 2 sine theta. Pair of 2 to the 4 or pair of 2, it will become 2 sine theta. So 1 over 2 is our sine theta. Solve for theta. It's tantamount to arc sine of 1 over 2. Arc sine of 1 over 2. That's equal to, I think, 30 degree or pi upon 6 radians. 30 degree or pi upon 6 radian in that case. That's the option in that case. That's the option. Again, A cross B is a unit vector. I have written A cross B is a unit vector. Mod A, magnitude of A is under root 2, magnitude of B is under root 2. Find angle. There is cross product. I have utilized the formula for cross product. A cross B, it is given to us. It is a unit vector. Magnitude of A is under root 2, magnitude of B is square root 2 sine theta. Solve for theta and it works wonderful. Yes. Question number next. Good question. I like that. The all tell us the angle. Tell it is of that if A cross B and dot and cross product are equal of two vectors. Dot and cross product of two vectors is equal. Then find the angle between the vectors. Their dot and cross product is equal. What is given to us? That's given to us. Where it's question? I think it's the question. Question number 6, 7. Yes, A cross B. Magnitude of A cross B is equal to A dot B. Then find the angle. A cross B is given by mod A, mod B sine theta, and it is given by mod A, mod B cos theta. They are cancelled out. Shift these quantities in denominator here from right to left or left to right. It's okay. Sine theta is equal to cos theta. Mathematically, they are equal in 45 or pi upon 4 degree. Okay, solve. Shift cos here. Sine theta over cos theta is equal to 1. Sine over cos is tan theta. Theta is going to be arc tan of 1. Arc tan of 1 is 45. Arc tan of 1 is 45 or pi upon 4 radians. Or pi upon 4 radians. Pi upon 4 radians. So option in that case is C. Option C. The last two MCQs. MCQ number 8. MCQ number 8 said that mod A is 10, magnitude of B is 2, and the dot product of the vectors is 0. Find the magnitude of A cross B. Find the magnitude of A cross B. What is given to us? Let's write MCQ number 8. Almost complete this frame. Question number 8. MCQ 8. Yes. Mod A is 10. Magnitude of A is 10. Magnitude of B is 2. And furthermore, A dot B is equal to 0. A cross B is equal to 0. Good. Magnitude is given. A dot B is equal to 0. When two vectors are perpendicular, their dot product result in 0. If A is perpendicular to B, then their dot product is always 0. Means from this one can infer, one can deduce, one can easily arrive at the conclusion that theta is 90 degree in that case. 90 degree or pi upon 2 radius. Pi upon 2 radius. Now we are asked to find A cross B. A cross B's magnitude. Yes. A cross B's magnitude is given by mod A, mod B sine theta. Magnitude are explicitly given to us. Our inclination angle is given to us indirectly. Only this one is given. Dot product A and B is equal to 0. From this one can arrive at the result. Their angle between them is 90. Why? Because the vectors are perpendicular. It is given to us. A is non-zero, B is also non-zero. A is non-zero, B is non-zero. The only possibility theta is our pi upon 2. So mod A is 10, mod B is 2, sine pi over 2. Sine 90 is equal to 1, 10 to the 20. So the magnitude of A cross B in that case is to be 20 units. 20 units. Option number D. Option number D. I have already told you how many vectors are possible to the plane containing A and B. A cross B is a vector that is perpendicular to A as well as perpendicular to B. One vector A cross B, the result of A cross B is perpendicular to A, perpendicular to B. It is one possibility. Second possibility is that A cross B and B cross A are anti-symmetric. This is also possible. B cross A is perpendicular to A as well as B cross A is perpendicular to B. So these two vectors are perpendicular to the plane containing A and B. A cross B and B cross A. A cross B and B cross A are the two vectors perpendicular to the plane containing A and B. A and B. So there are two possibilities in that case. So there are two possibilities that gives us a vector that is perpendicular to the plane containing both A and B. It's my tiny effort on practice. My each frame stands independent. Whatever you watch, it will give you a good concept, a handsome concept, an elegant concept. It's all by itself. Next.